But this one, I wanted to be a really good functioning driving car and as close to a real Batmobile as possible. I thought today I would tell you guys how I built the Batmobile. Yeah, the car that was known as the world's only turbine-powered Batmobile, which is a replica of the Michael Keaton film done by Tim Burton in the late 1980s. And then, of course, Batman Returns in, I think, like 1991. This one is powered by a turboshaft engine from a drone anti-submarine helicopter engine. So it was old war surplus that I actually got off of eBay, believe it or not, and an engine I've never done before. So I thought I'd just grab the camera and let's have a little fun impromptu walk around, and I kind of wanted to talk to you guys about how I built it and maybe why. So, you know, the first big thing about it is that I think you guys can understand is the Batmobile in the movie and in fiction was always portrayed as being turbine powered. You know, you'd hear the whine, it had the jet engine exhaust out the rear and the jet engine intake in the front. And even all the toys when you were a kid and schematics and things like that portrayed the Batmobile as being just that. But no one had done it. So of course I had to. Now, the first thing I want to point out is that if this car, all of the intakes and exhausts and radiators and all this jazz, if all of these things were functionally, like actually functioning, the car wouldn't possibly be able to exist. The reason being is there's a cockpit there. So let's think about it. If there was actually a jet engine that exited there of that size, okay, now look at it and then go ahead and interpolate the line going all the way to the front, to the intake in the front, there would be no cockpit, okay? I'm not sure what jet engine would be that large, but it's probably something out of a decent sized fighter jet, okay? So the other thing about it is, in making a jet engine, if you make a ground vehicle thrust powered to the air, it's gonna be relatively slow off the line. You're making such a commotion, you could never drive this thing on the street. It would be a drag car or a Bonneville Salt Flats car at best. And why would you do that with such a ridiculously draggy body? So the most realistic way to have a turbine engine power a ground vehicle is, well, maybe not the most. There's two ways to really do it. One would be like some trains where the turbine engine powered by fuels is actually driving a generator. Let me think about that. Yeah, a generator, which then powers electric motors to the wheels, which could be a great way to do something like this. Theoretically, you could also do that hydrostatically, but that's a whole other thing. However, I had mine, the output shaft of the turbine engine. You see how the turboshaft engine works up here. And you know what? I better just go ahead and pop this off because you guys are going to want to see it. So give me one moment here. Anyway, the turboshaft engine, it's called turboshaft instead of turbojet because it's not creating its work through a like jet or thrust into the atmosphere. It's doing it by taking that thrust or that so-called jet and internally directing it upon another set of blades. And those blades drive planetary gears, which reduce the speed of the rotation to an output shaft. So I did another video on how this engine works, so you guys can watch that if you want to go into it, and other things on like the cockpit of this and whatnot. But so I'm going to do a rudimentary one here. The intake is here at this screen. This works like a big supercharger here, compressing the air into two combustion chambers. Hope you can see that. There's one right here, okay? Kind of looks like this big nodule, and there's one over there. And the fuel goes to it, and there's a thing to hold the flame front inside, and obviously big igniters to start it. So you have your thrust here, and then it goes over driven blades here. And then if you look, there's two very large exhaust outlets on either side, one here and one over there, and they're both wrapped with a insulative material, basically the same stuff as you'd wrap headers in a car. And then those stacks are a very high-grade stainless steel alloy, and they exit out here. Now, this does not really create any worthwhile thrust to drive a vehicle, although it is very hot. And some of you may have seen my fun Halloween video where I roasted some marshmallows with a sword. So anyway, it gets us to the back part, the business part of the turboshaft engine, which is right here. This is where the planetary gears are housed. And planetary gear sets exist in automatic transmissions of cars. So if you've got a turbine here spinning, could be 20,000, 30, 40, 50,000 RPMs, you want the output shaft speed to be something reasonable. This particular engine's output shaft usable speed is 0 to 6,000 RPMs, and it actually rotates in the same direction as the output shaft of a conventional, say, small block Chevy. So, what do you think I did? If you have a look here, you can see this about 1.25 inch thick billet aluminum plate and this tie rod here that I have on for torque, just to have the motor mounted really nicely and so there's no torque. Anyway, inside that plate, first of all, it bolts to the output, the big flange of the engine here, and it has a high-speed bearing and a seal in it. And then I did the drawings to have an adapter shaft, which is a male spline shaft, which slides through the bearing, and it has its own journal surface for the bearing, but the spline shaft goes into the female splined output shaft of the engine. So then your torque is going through that shaft, through the bearing, and outside here is an output flange, which I had made be identical to that of a small block Chevy. And then back here, I'm able to run, believe it or not, a torque converter, which I know some of you that know turbine engines say you don't really need, but there's some reasons I did it just for cushioning and making it easier, et cetera, et cetera. And that adapts to a 4-speed automatic gearbox, which has been modified to be manual shift only. So, oops, shouldn't have pushed that forward so bad. It's fine. You can see the shifter down there, actually made by B&M, and you simply ratchet it through gears, as is appropriate when you look at the RPM on your output shaft speed. So when your output shaft is getting closer to 6,000 RPMs, or you're not trying to rev it up real high to make the torque in the lower gear, you pull a higher gear. And that's how you pay attention. So the RPM gauge you pay the most attention to is the output shaft for the sake of the gears. And then of course you downshift, you know, when you want higher torque and you're getting way low. And then back here in the replica, this is of course faux or dummy, just like it would be in the movie. Now, it would be fun. You can always make a flamethrower shoot out there. This one had one, actually. And because those are massive liabilities on street-driven vehicles. The Simfire machine guns on there are a lot more fun noisemakers. So that is really how that works. It would be fun back here if you really wanted to have a jet engine for thrust. You're really not going to make the car go any faster, but it would be cool. There's some small ones that you could potentially put back here, but keep in mind, if you look between where the wheels are and approximately the center line, which would be right about here, going straight down, the differential, and there's a lot of suspension and stuff going on here. So you really have only about 2.5, 3 feet for the length of putting a small jet engine in there. So if you did that, it would really just be for sound and show, which is really not necessary when the whole car is already driven by it. The downsides to having a turboshaft engine driving a ground vehicle in that way is, of course, lag, and more lag! Why am I so ridiculous? Anyway, so the reason it has lag is because turbine engines, you know, they make basically all of their thrust and power when they're at higher RPMs. So if you're just sitting there idling at 20,000 RPMs and punch it, it's going to be like, and then it'll eventually do something. So if you want to come out of a corner faster, or you want to come away from a traffic stop quicker, something like that, you simply just left foot brake, you power brake it, and you get the gas generator up a little bit, and you release the brake and hit it, and you're off to the races. So that's really how you drive it. Couple of noteworthy cars that drove the wheels through turbines were, of course, basically all of the cool Indy cars in the 1960s that were turbine powered. And a personal favorite car of mine, the Helmet turbine car, which is actually one of Bob McKee's chassis. So it's really a McKee with the turbine engine in it that was like modified up. So Bob McKee's a real big hero with that, and neat guy. I've met him in person. He's been real nice to Genius Garage students. But the thing that was at Indianapolis, the reason these turbine engines that worked out so well, besides the fact that they could cheat easier, was that, and I'm going to set this down, my arm's getting tired. Shut up, internet. So The thing about the turbine engines in Indy are turbine engines are lighter weight than a reciprocating engine because lighter weight materials, thinner. And so that's a good thing. You don't need a cooling system other than maybe one for your oil, which you can probably see on the Batmobile reasonably well. Just there, that kind of bronzy gold color thing right there, that's an oil cooler. So that's the only cooling thing on it because the heat really comes out the exhaust and is gone. There's so many less parts and so many less things to break, and that's why they're so great for aviation, for military use, etc. But turbine engines like to make a lot of power and stay at the same RPM for a long time, which is great for IndyCar racing on the ovals. Not so much for the road courses, we have to speed up and slow down and do all these corners, but at Indianapolis, when you're just hauling the mail, if you have a lightweight engine that makes a crap load of power that wants to stay there, that's awesome if you don't have a fuel concern, because they do use a lot of fuel. They're not as efficient because of that, some of those reasons there. The Howmet turbine, though, was pretty neat because, and I know I'm getting sidetracked, I'll come back into building the Batmobile. But the Howmet turbine was neat, and how they solved the issue with the lag coming off the corners, they would run the gas generator basically full throttle, and they had a giant wastegate. So they would open the wastegate when they didn't want to make power. When you come out of the corner, they close the wastegate, and it would just direct all the thrust, so it would be better. But this particular car, a lot of people have asked me about how to make the body. Truth be told, I didn't make the body. It's exactly accurate. You guys can do some searching and figure out how to do it. But every once in a while, or if you look real hard, you can find a shell that basically traces its lineage back to the movie cars. Okay, so it is dead on accurate. And it's made of a really nice fiberglass, and obviously I cleaned it up and gave it a great paint. The best I can tell, one of the mistakes people make when they made some replicas are painting them total gloss black. I hate it when they do that. They're just going over the top for show. It really looks better with a satin to where it just has a sheen. And flat black is wrong too. So it's the right satin. So anyway, the shell was already a thing, but that's by no means a car, and by no means can you just slap this on something and have it be a worthwhile vehicle, not just some junky prop. The ones from the movies, I believe, were built on stretched Impala chassis, and they were good for the movie. They had a crummy carbureted Chevy V8 like way up in the front, because it was never going to get taken apart, never get looked at. So it didn't matter if it was really that great. But this one, I wanted to be a really good functioning driving car and as close to a real Batmobile as possible. So, you know, everybody likes to think, well, I'd like to build something from the ground up to this tube frame, all this great suspension, everything like that. I'm like, okay, that's great, but lots of people have made lots of things like that before, and there's a lot of other factors you need. So what I did was what I think about any red-blooded American would do. Went out and bought a Corvette. Heck yeah! No, a C4 Corvette is a great platform because you can buy them economically. They have good suspension. There's lots of things to modify them. It's a well-known quantity. It has kind of a mix between a classic frame and then sort of a unibody in the middle. So, and it's all steel, so you can cut it and weld it and make whatever you like. The C4 Corvette chassis is something like a 95, 96-inch wheelbase, I think, if memory serves. And the Batmobile wheelbase is in the area of 136 inches. So it's actually closer to being that of a big turbo diesel dually pickup truck. So you can't just use a chassis from a normal car. I mean, you can extend it. The problem is if you just, let's say you took a Corvette chassis and just chopped it in one place and extended it, nothing's gonna match up well, okay? So I actually cut the car apart into 3 sections, and like everything was gone. There was no more firewall, obviously there was no more body work, none of everything. It was stripped way down to the basics. I think about 75% of the original suspension I just got rid of. I sold it all, I trashed it. It was no good. So it has totally custom suspension. It is in fact running on pneumatic airbags to be able to raise and lower it. And you need that if you're gonna drive on the street with it having such low overhangs as can be illustrated here. Right now it's sitting on the ground. The rear is not as big a concern, of course, as the front, but if you have any undulations or things, I mean, gosh, the people that have ride height to pick it up on a Gallardo, that's no sweat compared to something like this. So you really need the pneumatics, and that works really nice. You can control all 4 corners. And it has to have a rather long drive shaft as well. So I had a custom drive shaft made. And the C4 Corvette, by nature, the The engine mounts with the two Chevy mounts, kind of like on the side of the block to the chassis, and that's similar. I think I had to custom make mounts because the frame is totally cut apart and totally different where it would be. And obviously this doesn't have a Chevy engine in it, but if you were going to keep the Chevy engine in it, you'd have to do that. So obviously I sold the engine. The turbo shaft, there's plenty of room to do it because it was a lot of stretching going on there, but the transmission is still in the same basic exact position in relation to the steering column and foot pedal assembly as it would have been in the stock Corvette. Of course, the transmission's relation to where the wheels and wheelbase are has totally changed being in this, hence why I had to have the longer drive shaft. Now, as a note, the rear of the transmission doesn't mount to the frame in the C4 Corvette. The transmission mounts to the engine in the C4 Corvette, which is mounted to the frame with typical Chevy kind of motor mounts. And then the rear of the transmission in the C4 Corvette is mounted to this high-strength aluminum alloy ladder sort of thing. It's like this C-shaped beam with like an X pattern cut into it. And then that goes back, and mounts to the front of the differential. So you don't have any of that torque crap going on. It makes a rigid structure there, and then the drive shaft, which is also nice because the drive shaft doesn't have to go in and out of the back of the transmission really, because it's all rigidly mounted there. So naturally, a new one of those beams had to be fabricated that was much longer also. Still uses the stock C4 differential with the big ladder assembly with the bulkheads, the stock bulkheads in the back, and that's really about it. There was not much kept of the original Corvette. The suspension pickup points are about the same. It has totally custom suspension on this one. Obviously the leaf springs are gone, long since gone. It does in fact use Corvette-based brakes, General Motors brakes, and it does the 4-speed automatic transmission that was, it's the 700 R4, which actually was in the later C4 Corvettes. That's the one that I modified for usage on this. This turboshaft engine makes just shy of 400 horsepower, which is nothing astronomical, but let's face it, that is perfectly well suited to something like this. And it's a great engine with a great look that absolutely looks the part of reality in there. So just really good solid choices, and certainly there's turboshaft engines and jet engines that make 1,000 horsepower, 15, 2,000 plus horsepower. But let's face it, if you had that in this, it's already a silly, absurd machine that's somewhat limited in usage, but unlimited, of course, in fun and collecting. But if you put in something that had 1,500 horsepower, it would be virtually useless unless you're on a drag strip. So that wouldn't be nearly as much fun when you want to have the fantasy of the Batmobile. The machine guns here, the Browning 30 calibers, these are not real Browning 30 calibers, they just look like them. None of the parts there are actually interchangeable for an original firearm. These are replicas built out of an aluminum body, CNC'd. It still opens, kind of like the original one does here. There we are. And the ammo chain I've got off right now is cleaning them. And it's not a real receiver. You cannot load a round into it. So it's not a firearm, it's merely a prop and a noise maker. As you may be able to see here down below, there is an oxygen and propane line with flashback arresters. And inside the body of the faux machine gun is a computer controlled circuit and a couple of solenoids and of course an igniter in the little combustion chamber. So when you hit the firing, the button, you energize it, and it starts clicking the solenoids, and you have your oxygen and propane adjusted to the right PSIs of each, and that allows you to adjust the richness of the blast, and it fires and does the explosions at the right cadence of the original machine guns. And it's also fun too because you get a good 2-foot-long muzzle flash out the front of fire, which is just great fun. And you know, people that are into real firearms know when they hear it, it's not a real gunshot because you do not hear a round or projectile breaking the sound barrier, as well as you don't have that extra concussion from the round coming out. But it is exciting. It's convincing for a show, of course. But I don't think anybody's so crazy as to think they're real machine guns on there. Not only would that be incredibly expensive, that would just be opening yourself up to a world of trouble. So those particular ones are made by a company that does simfire weapons or faux weapons like that for the movie industry, as well as, I guess, for the military, for some training type things or displays. I'm not sure. But that's that there too. Fun little tip I'll give you guys just for clever scrappiness. The exhaust here is a high-grade stainless steel alloy. It's rather thin, and I had to get one a nice 45-degree bend, and I had to shape it then to go from a round cross section to a rectangular that it could match up and mate up to the stock output of the engine's exhaust. And then of course I got my EGT exhaust gas temperatures here, insulated it, and also used springs to hold it on, as you do. Now, those were tricky to find, that alloy, because it's a rather large diameter, and I didn't want it to be super thick. I'm like, where am I going to find stainless steel that's of the alloy I need? Believe it or not, if my memory serves, I was actually able to get those tubes that have worked perfectly, mind you, from high-grade European kitchen industry for the smokestacks of their cooking things. Apparently in Europe, they have really, really high standards for that. And the best place I was able to get what I needed was to order, you know, commercial food cooking grade oven plumbing from Europe. Crazy, right? And another thing, and I'm giving away some secrets right now, but so the centers of the wheels here, these wheels are aluminum. Actually, they're typical for what drag racing. Some of you drag racer guys, hot rodder guys will probably recognize them. I don't want to take away all the magic or give away all the secrets, but they're the same as what was used in the original car. But this stainless steel guy here, this spun piece, now you could have one of these made, spun out of aluminum or stainless, and there's a nice aluminum ring here, which then I drilled and tapped to the wheel, so you can bolt that on, and the flange holds this on. Well, this is also something I utilized and thought of it. That's I think you call it a Bain-Marie. It's literally like one of those tubs you put in a buffet line, like if you're putting little cassava melon balls or watermelon in it, and a thing. But it works perfectly. It's a perfect stainless steel thing. It was already formed, exact right size. And, you know, you can hate on me all you want because I used a kitchen product, but it works perfectly. Some other fun things about it. The taillights, my vintage European car enthusiasts will recognize the taillights from being the same that you'd find on, say, like a Ferrari 308 or I think like a 512 and some other cars from the 80s. The smaller ones down there can also be the smaller Ferrari taillight. These particular ones, I found a better look of ones that were actually, I think they're like a 20 or 30s hot rodder remake. They're glass and they fit even more perfectly than the tiny Ferrari ones. So went with the correct Ferrari taillights on the top because those are very recognizable from the movie. And for the bottom ones, I went with those hot rodder ones because they actually look a little better. So I used just a minor bit of artistic license so you get the same feel, but in reality works better. Another little couple secret stashes. This is not a porthole. There's nothing back there. That was just a thing in the movie that I replicated. These Le Mans filler caps do not actually go to anything, but they were in the movie like that. You could make them go to something, but it's not really worth it because it would be an ugly angle to fill it. So where I actually fill this vehicle is, you can see a flush mount filler there up at the top, which actually is similar to what you might have on a boat deck. And you can fill it with jet fuel right there. I like to run the thing on Jet A because it's a jet engine and I just want to make sure you don't hurt it because it's not like there's loads of these old jet engines laying around. But you can also run it on diesel or kerosene, and the truth be told that basically jet fuel is just a little more purified or glossed over kerosene, in all honesty. There is a little adjustment there on the fuel metering thing for the specific gravity, so the type of fuel, so you could adjust it, but for the limited usage it gets, just run it on jet fuel. And I'm trying to think if there's any other fun little secrets I can tell you guys. No, it's a really neat car. It's really solid. It's really reliable. We changed the oil on it the other day. That was fun. That's real easy. It was kind of fun. I was being a total goofball and silly. I hope you guys didn't mind. Having a good time. The faux front intake up here, or the dongle as I like to call it. Actually, I don't really like to call it. That sounds creepy as heck. Let's see if I can show you guys that. I'm going to take the camera off. Hold on one second. But the dongle, as it is supposed to be in the movie, the jet engine, right? So this is where I've got to make something that was to be a prop be real. So obviously it looks like the front of an inlet of a turbine in there. The back blades here are fixed out of aluminum, but this front one is a painted aftermarket radiator fan. Painted aluminum, look really good. but the electric motor for it is inside and behind here. So I can flip a switch with that, and it turns into just a giant ducted fan to actually cool the oil cooler here that I showed you guys, as well as the oil cooler down there for the automatic transmission, and generally blows some cooling air over the engine bay and exhaust, which obviously can exit out the bottom of the car, but can go around the exhaust, and there's also channels sort of through the body. There's a screen here. Some of the hot air of the exhaust can come out through here. That's nice too, with louvers that as you're moving creates a little bit of a low pressure. And some of that can flow through the channels in the body and out. The intake on the side here and here are fake, but of course if you did something crazy you could easily put a radiator in or something there. But yeah, that's just kind of want to give you guys a fun go around of making some old movie magic be reality, and just the fun I had a good number of years ago doing just that. But it's really old school hot rodding, you guys. I know a lot of you have really said some nice things about creating it, and think it's so cool. But I got to give credit to the hot rodders out there in the past that have made turbine-powered cars. I'm not the first guy to do it. I was just the first guy to do it in something that looked just like a Batmobile and have a lot of fun for that. But this is just good old school American hot rodding and custom car building. There were no directions for me to do something like this before I did it. I just really thought about it and looked into it and thought, how do I do it? What do I know about the original? Where can I get the stuff? Where can I have a garage? Will it fit in my garage? What are the resources? What am I going to do? What if I can't solve all the problems? But there does come a point where you have to realize, I think I can do it. And here's the basic resources and all the things that I don't totally know, I know that I can overcome, and I know that I can find the right places to do it. So I didn't necessarily have all the tools for it, but I had enough. And I had enough resources and a few people to ask. And the Turboshaft engine, honestly, when I got it, was effectively seized. It had been sitting for so long that whatever it was that was either pickled with or whatever oil that was still in it basically turned to paraffin wax. So I had to largely rebuild the whole thing and flush it out and make it nice, and fortunately was able to get everything happy and working properly again. But if I hadn't done that and I tried to run it with it not being perfect, could have easily just destroyed it or disintegrated oiling type things or something like that. So, that's where, young people really have to take an initiative and understand that you don't have to have had to go to school for everything. You don't have to already know how to do something to do it. You just have to look at the whole situation, consider all the aspects, the resources, look at yourself, your tools, what do you have to do, and just know how to assess a situation to overcome an obstacle and create something of your desires. And I think that's a very important lesson, and I hope you all can think of that. And by no means is that a knock on a school or education, but I can promise you there's no class out there in Batmobile building, okay? And if you want to go out there and do something that no one's done before too, there's no class for it. So you're going to have to figure out where to gain knowledge of all the aspects of what you need, and then of course how to do it in the end. And that's the same holds true with other things like that, the world's only full-scale flying pterosaur. I'll look at it real quick. I know this is a Batmobile video, but check it out. This is my closest estimate of what a Quetzalcoatlus northropi was, which was the largest flying pterosaur of the late Cretaceous era. And this one is sitting here at a 38-foot wingspan. Here, look, I'm going straight down to the Batmobile. Look how long the Batmobile is. It's like 20 feet long, okay? And the Batmobile right now, if I walk over to the end, here, let's do a one-on-one comparison. Okay, front of the Batmobile, right at the end of the wing of the pterosaur, right? So let's walk down to the end of the Batmobile. Okay, here's the end of the Batmobile, and we're at the center of the pterosaur. The rest of the pterosaur comes way over here. I'll do another video on it sometime for fun, guys, but that's something I designed in my mind and had to give consideration to flexing the wing membranes and getting the airfoil and considering all the biomechanics from a fossil. How cool is that? So it's those kind of problem solving and thinking and creativity and just excitement of engineering and design and solving mysteries that's so much fun, and you can make something real cool. So I hope this inspires you guys to modify, enjoy, restore, and build your own cars and things, whatever they may be. And that, of course, you've enjoyed the video today. I hope, naturally, I want to lean on the Batmobile, cool. Yes, I'm going to lean on my Batmobile. Naturally, I hope you'll share this and that you will like, comment, and subscribe. I'll see you guys next time. There are many tools, tricks, and products that help me do all these automotive adventures. And one of them is ceramic coating by Avalon King. This stuff literally bonds to the molecular level of your paint to keep that long-lasting shine for years. And better than any old conventional wax literally can. Nobody actually has time for wax on, wax off anymore. So give Avalon King a try. You can go down in the description, buy some. You're going to be glad you did.